Kia ora, thank you for joining us on this Zui today. Ena mana ena reo, rau rangatira mā, tēnā koutou katoa. Hei karakia timatanga te tātou. Whakataka te hau ki te uru, whakataka te hau ki te tonga, kia mākina, kia uta, kia mātaratara ki tai, he hi aki ana, tia tākura, he tio, he huka, he hauhonga. Tūturu, whakamaua, kia tīna. Tīna. Haumi e, hui e, taiki. Kia ora koutou, and welcome to our wānanga today. Great to see some familiar faces out there. And so this session is being recorded, so you will be able to come back to it and have a look after. So if I could just ask if you can mute your microphone, and we'll have time for pātai at the end of this session today. We'll also, if you have any pātai, please do feel free to put them, any questions, put them in the chat, and myself or my colleagues will have a look at those for you. So today, what we're going to be looking through is mapping sea level rise in Aotearoa. So there are a number of different data sources available, and what I wanted to do is just focus in just on sea level rise data. So we'll have a look at some other risk management tools, but we're going to focus in just on elevation in relation to the whenua and identifying some of the implications for that. So I'm just going to share my screen, and I'm also going to just put in the chat for you. Just make sure everyone can get this link. There we go. So just in the chat is a story map, and that has a heap of different links. In the past, we've used a single one-page Word document, and they're not too cool to look at. But with the story map, it's a good example of how you can use some of the geospatial technologies to share information with friends, whānau, trust board, whoever your audience may be. So what I'm going to do is I'm going to share my screen, and we're going to have a quick look through this. And what I want to do is encourage you to have a tutu as we go. So if I share the screen, just make sure you get that working there okay. And then I'm just going to move the chat over there. Okay. So can you see the screen okay? Mapping sea level rise?
Right.
Hi, kia ora. So you've got the link on the chat. You can go through this together or just sit back, relax and watch. So we've pulled this together as a bit of a resource for exploring different sources of GIS mapping data. So GIS mapping, of course, is like Google Earth, Google Maps. You may have seen some of our earlier wānanga, basically putting layers of information over the top. So today we're going to be focusing on elevation, mapping, sea level rise, where the whenua is, identifying Māori land blocks, and identifying that in location to marae as well. At the top of the story map here are some quick links that will drop down through. So here are some of the things we'll have a look at today. This is intended as a resource. Sea level rise predictions, and it's also important here just to note that I'm not an expert in this. There are, many other experts in sea level rise, climate change. My specialty is in understanding where data is, and then hopefully putting it and presenting it in a format that others can find useful. So we'll have a look at how to access existing maps and tools. So there's a lot of work already been done, so we don't need to reinvent the wheel. And I always make a joke, if you ask a lazy guy like me how to do something, well, he's not going to do it the hard way. He's going to find what's already out there. We have a look at how to identify impacted whenua assets in Tonga, and then communicating with whānau as well. Now, what I wanted to do first is I thought it might be quite neat to share with you some personal learnings from work and mahi that I've done over the past few years. And the first one is I used to work full-time at Toitū Te Whenua, now at Stats NZ. And something that the staff in Toitū Whenua Linds do is every day, more than once a day now, Jeff, please correct me if I'm wrong on any of these bits, there is a station in Wellington, and let me just zoom out here. So I'm going to make some sense in just a moment, but this is Wellington, Beehive's over there, Cake Tin's over there. Just here on Queen's Wharf, there is a small room. Unfortunately, the street view doesn't work here. Just next to this restaurant, just at this location, there's a wee door here, and you can go in there, and there's a tide gauge, and that tide gauge has been there for a long time, 76 years. Coming into that tide gauge, and here is the monthly average data, and we used this a few years ago for a virtual field trip with primary and secondary students. And I was looking at this and I was thinking, here we go, Wellington sea level monthly mean, monthly average, 1944 to 2020. Because one of the things for me is how do we know that this information is correct? How do we know that, you know, the sea level rise is happening? And so for me, I wanted to localize it for students as well. What I want you to do is have a look here. This is the end of World War II. World War II finished just here, May 45. Have a look at the numbers on here, and we'll just do some mental averaging in here. So we got 912, just skim down here with me. 912, 1013, 1920, 57, 62. Skim through there, we got 9s, 900s, kind of, you know, bumping around 1,000, 900s. And now if I go a bit quicker through the list, you can see some 900s, couple of thousands. Oh, there's a chunk of 1,000s. And of course, these are average things. And there's all kinds of stuff in this. You know, there's moon activity, there's tidal forces and cycles and things at play. But if you have a look there, we've got the first one in April 56, you know, just sort of getting into the industrial age, 1141 millimeters as the mean tide. If we carry on, we're getting more of the 1,000s coming into this list now. We've got 900s, 1,000s. We're getting less and less of the big blocks of 900s, and now we're getting into 1,000s. Now, if we carry on skipping through the 70s, something is changing here. We're getting more of the 1,000s, so 4 digits, just skimming through here. And when we get into 91, look at the difference here from 45. Carry on through, and in about 1997, I think is the last time that there was a 900. There it is. A 900 number. Now, what does that look like? This is useful to just see the data. So, you know, this is scientific data. There's no bias as far as I can think of in there. This is what that graph looks like. So this is what we saw in the data, a gradual rise of about 20 centimeters. So if we were to draw a line through there, the average would go from something like 900 to 1,100. But that data is there. You can have a go with it yourself. Just down here is that sheet, and here is a chart based on that sheet. So if you change those numbers, that chart will update. But I thought that was just something that really stuck in my mind from a few years ago in terms of sea level rise. It's already happened, not happening, it's happened, and it continues. If we also have a look, what are the causes for that? Of course, we all know that carbon dioxide is increasing in the atmosphere as we burn fossil fuels. We increase the level of CO2, and CO2 absorbs more heat. So as a result, this is where the greenhouse effect comes. And this is why in tomato glass houses, they pump CO2 in there to warm it up without having to heat it. Also helps the plants grow faster. In the 70s, they started measuring, not far from here, I'm in Petone, down off the Wellington coast, where they get the fresh air coming off the Antarctic. The particulates per million think it's per million, I should look this up, of carbon dioxide. And you can see here in 1978, quite scientific, quite accurate, 333 parts per million. And you would have seen this in different articles and stories, I'm sure. But here's another example of that carbon count. I get rid of my teams there. Exit out of there. That carbon count increasing up until the latest of this particular data set, 405 parts per million. And then when you graph it, this is what that looks like. And because this is the basis of how scientists have established there's a relationship between greenhouse gas and sea level rise. So I thought that was just a really, and there's a neat story map here. I'll just click on that one too, just to show you. Here he is capturing Dave Lowe, capturing samples of carbon dioxide into a flask and then taking it and doing measurement on it. And you can see all the instruments in the background there. So I just wanted to put that out there as this is what it's all about. This is where it all comes from. This is why, this is some of the, the data, because there's a lot of, conspiracies and theories and other things, and I don't pay too much attention to those. Just always come back to credible sources of information, or find it out for yourself as you can in here. And there's all kinds of, peculiarities to that. Okay, so we had that science. Organizations such as Toitū Te Whenua have, they very recent, last few years, put together a business case and got some funding for LiDAR, laser-driven, laser and light detection scanning of most of Aotearoa. And I'll just see if I've still got this one open. Might have to go and find that one. So coming down here to NIWA, there are a couple of websites that I want to introduce you today. First one is the NIWA Coastal Flood Mapping Viewer. And the second one is in relation to sea level rise and vertical land movement, because of course the sea can be rising, but if the land is coming up as well, as it is on some parts of Aotearoa, other parts sinking, this has an impact on the level of prediction for those areas. And all the different areas are different parts of Aotearoa will have different predictions. And there's a whole lot of videos here as well that I've put in there just to go through vertical land movement, impact on sea level rise, why in some areas will be marginal change, even though the water is coming up, doesn't necessarily mean it'll have the same impact. And then also further down in the story map, there are some links to some of the regional council viewers, which of course have got more localized detail. And I've put together towards the end here a 2D web map that we can have a look at, as well as some other stories, one from last month's Wānanga, and a couple of other examples of story maps. For example, this Marae Development Plan is a nice example of how you can share this kind of information with friends and whānau. Now, let me just grab the chat there. Just check we're all going okay. Can hear me okay? Cool. Thanks, Keith. Kia ora. Okay. And somebody put the, currently 425 parts per million. I think Stuff for a while used to have it on their front page, but I notice it's fallen off recently. Okay, so let's have a look at this one. So if we just drive straight into the meat and potatoes, this is one of the most useful tools in terms of very long-term sea level rise that I've found. Works just out of the box, ready to roll. And that's a link from the story map in there. So we'll just close this stuff. There's some technical description here. Always disclaimers, which is fair enough. But here's what I found really useful. We're just going to zoom in here and I'm going to press play. So I'm just over here and put it on. Press play. What this is doing is this is using very detailed elevation data and some modeling, scientific modeling, to show at what levels, a centimetre of sea level rise, these areas are likely to be flooded or affected, because they'll be affected before they're flooded. That's the thing to remember, is it's not so much the water coming up as the impact of the water, seawater, before it gets there, such as the water table, saltwater intrusion, killing off vegetation, particularly in places like Hauraki. So this tool, this one here, NIWA Coastal Flood Mapping Viewer. If we have a look, let's go and have a look at another location up the East Coast somewhere. So Bad Plenty, unfortunately, is not there in this particular tool just yet. If we come up here to Te Araroa, and let's see, let's have a look here in terms of Te Araroa. If we just let this run, I'll just come back here. We can see here, what it's using is that very detailed elevation data. And it's showing you, depending on how many centimetres of sea level rise, the likely areas of impact. And what you can do is over on the left here, you can use some of these settings, and they take a bit of getting used to. But if we pick some scenarios, so let's go with this one just for target year. Let's go with, say, 2050. What's that, 30 years away? So we're looking at potentially 14 centimeters, say, or 0.2 meter rounded up. So what we can do is we can come over here and we can go, okay, if that was 10 or 0.2, we can zoom in here and see what likely areas are going to be the most affected. And because it's not the impact of just the seawater coming up, there's the impact of the storms and other significant weather events before that happens. Okay, so that's quite a neat tool to have a play with. Best thing would be to have a look through and read through the preamble, just to understand what it's showing you. Now, let's have a look at the coastal flood layers. So what is the data that's made this up? So some of you, I know a couple of colleagues on here will be using QGIS, and this is a thing of doing it yourself. You can go here and you can download all of those data layers that NIWA have prepared for us. And it also describes this annual exceedance probability. So 1%, once in 100 years is what 1% represents. So when you see this sort of annual impedance probability, AEP, 1% means 1 in 100 years. But there's some information there. You can have a read through if you're more into the metadata and detail there. And you can download it in file geodatabase format. And there's a wee note here just of what exactly does that 1% mean. Okay. Now, the next thing I wanted to share with you is this concept of, we've seen that kind of linear increase in sea level. We've seen the linear increase in carbon dioxide. In addition to that, the third part, when we come to locally, is the movement of the land. In some areas of Aotearoa it's coming up, some areas it's coming down. So this concept of vertical land movement, or VLM. Now, Sea Rise is a recent website that's been put together. I think it was partnership NIWA, GNS, and Takiwa. And if we jump straight to the maps, because that's what we want to see. This one is a bit different in that it is based on points rather than areas, but it does have some useful data in here that's a bit more detailed than what you can see from that NIWA data. So if we go for public, and we read through the disclaimers and we go, yep, we're happy with those. And I'm just going to zoom out a bit just so you can see it better. So over on the left, on the right here, you can see this vertical land movement graph. Now, if we come down to Onofano and they asked us to have a look at Queen Charlotte Sound, for example. If we come down here, wait a moment for those dots to draw. And so every 2 kilometers, they've done some sampling, and the methodology behind this is using satellite measurement, radar, which gives them averages of ground movement as well as sea level. So if we click on one of these, and just to point out which one this was on the story map, this is Sea Rise program. Here. So what this allows you to do is for that location, for each of these locations you can see on the left here, it allows you to pick a scenario. So we haven't covered these SSP scenarios yet. These are basically different types of scenarios that have been put together. The smaller number, the smaller scenario, these kind of scenarios assume that the big carbon dioxide polluters do something about that, and we move to a reduced carbon output scenario. The higher ones are where just business as usual or even increase. In a nutshell, if we aim for the middle one, for the meantime, this is going to give us a reasonable idea. Now, if we turn this one on and off, this is just sea level rise. So this average through the middle here, we can see if we use 2100 in what's that, 80 years, just about. We can see here for this location, we're looking at about, on average, between, and I'm looking at where the little finger is, and then also on the left over here where it says 45. We're looking at between 42 and 74. So it's quite a range. And you can see the P50, P17, P83 just in the middle there. It's giving us that range as well. And if we come down here to the middle line, it should, it's going to make me a liar, on average about 50.5 of a meter. So that's sea level rise. But if the land is dropping, that's going to be more of an impact. If the land is rising, it's going to be less of an impact. So if we click and turn VLM on, vertical land movement, now we're looking at that same area, and we can see there's quite a change in what's going to be happening. You know, at most it could be 1.07 in 80 years. 80 years? Maths is failing me. 76 years. But you can also see it's coming back, if we look back in here, 2024 or so, we can see, get an idea of what the most recent sea level rise has been and look towards the future of what is it most likely going to do in that area. So what you can do, you can also save that chart out there. You can also download, if you're into the data, when you come back to here, just click on planners, and there's a download data button up there. You can see there, you can download that data, but to be honest, it's quite challenging to go through and set up the data in GIS to show those graphs and things, but it is possible. If we have a look in some areas here now, they've done it for the whole Motu. We can see here in Bay of Plenty, we've got vertical land movement being higher. And if we have a look, I think from memory down here on the coast, Wairarapa, we've got land movement sinking. So different parts of the country have got different rates of change. So vertical land movement here on the west coast is 1.6 coming up per year. over here near to Christchurch, probably not too much. So there's the Sea Rise site, and it's worth having a look through some of the technical papers, some of the descriptions. I've gone past and click past disclaimers, but do have a read through there because it explains the methods and the data sources and things for you as well. And if you're really into, some of you, if you've not already seen, there is the International Climate Panel Committee, IPCC, and they've put out lots of different scenarios and things, which is what these models are all based on. And there's an explainer there as well from the Sea Rise, which will describe it far better than I have. Coming through here, we've got some videos from GNS, which also associated with the Sea Rise project. So it's kind of, you use the Sea Rise project to get an idea. Once you're familiar with that sort of the land movement and the value for your area, then you can have a look at the NIWA map, and it will show you how far inland, for example, particularly on those low areas. Now, there's some other sites I wanted to share with you. This Natural Resource Hazard portal, and they've done a great job of pulling together all of the different regional council portals. Let's have a look here under climate change. There's some information here. National Adaptation Plan, natural hazards in your area. That's the one we want to have a look at. So coming on to this page, if we go and have a look at, let's have a look for Northland, Tokoro, we can see here some links onto the Northland regional mapping sites as well. Map viewer there. Oops, just click the wrong link. And this will take you straight to that resource where they'll have layers of information that you can grab for your area. And the simplest way, if you're wanting to take a copy of it, is to screen grab it. And I just use Shift, Windows key, and S, like this, if you wanted to grab capture anything off the screen. Zoom out a bit here. Okay, so that's Natural Hazard Portal. It has all kinds of information here for all the different regions. Here's some information about we looked at that NIWA data first. There's a link here that describes that piece of work, that project, in more detail. So this relation to the sea rise projections, and then some coastal flood maps from the councils. Many of these will be the similar ones to the Natural Hazard Portal. Let's have a look at how do we overlay the data that you've seen with marae, land blocks in your area. So I'm just going to put this one on the chat. Here we go. Now, if I zoom out here. So what have we got here? I've brought in and created this relatively simple map of marae, which I'm getting from TPK, Māori land blocks, which I think also come from TPK, but of course by the Māori Land Court or MB, who might host the data. So we've got marae land blocks and 3 data sets from NIWA. So we've got the 10, to save me having to republish and rehost, which cost me money to host it, I've just used what MFE and NIWA have shared online and made it available to you. So you can have a to-do with this at the same time. Now over here, if we look for a marae, let's say Hinerupe. Marae. And in this app, I've made it so you can search by land block, marae, or just general names. So here we've got Hinerupe marae. And if I come over to the left here, this little layer sandwich button. This allows you to turn on and off those different layers. So let's say you weren't necessarily interested in having the land blocks turned on just for now. If you wanted to turn them off, just expand that group and turn it off there. Now, what that lets you do is see that data from NIWA that you've seen doing the increase over time. You can see there for this marae, the marae will probably be impacted because you've got sea levels coming up, but not necessarily directly. You're still going to get the impacts of storm, surge, and other extreme weather events, as we've seen in the past couple of years already occurring. Now, something else interesting to see here is you see these blocks, these kind of this Lego pattern. We can also turn on and off under the NIWA exceedance group here. We can turn these ones on and off to have a look as well. So the red one, for example, is, I can pretty much tell you it won't happen in our lifetimes, perhaps in our grandchildren's lifetimes. This first one, however, 10 centimeters is very much in our lifetimes, probably around 20, 30 years from now. So that will mean where we have sea level at the moment, and it's important to recognize that sea level is a very difficult thing to measure, very difficult thing to map, rather. Where you have a coast, that coast can move. You've got mean high water springs mark. You also have varying models and elevations for around the coast. So if you imagine a map of Aotearoa on a globe, it's not a perfectly smooth globe. It's more like a mandarin that's sort of drying up a bit. It's bumpy. And so the sea level is not a straight line all the way around Aotearoa, or it's not dead flat. It changes depending on things like gravity, moons, tides, weather, currents. All of these kind of things have an impact. But this allows you to turn on and off those layers and see, probably the most extreme 1 meter sea level rise in most areas, just from my own viewing. That's probably about 50 years away. But those impacts, of course, will, it's not 50 years and then suddenly 1 level up. It's 5 years and we've got another 5 or 10 centimeters of the sea coming up, and all the impacts that go with it, not necessarily just day-to-day flooding like perhaps they have in Miami. If you've seen any of the YouTube videos on Miami where the streets flood in high tide, there's also a part in that the land is subsiding because they're taking out fresh water. And if I just point out, there's a spot you'll often see, and it sometimes does kind of, I do sometimes question whether it's being used the right way or not, is there's down here just down here, there's some, just forgotten the name, Homoana, I think. There's some houses right on the beach, and I had a look in some historical imagery from RetroLens. I'll just put that link in here for you as well. RetroLens, if you've not seen it already, retrolens.nz. You can go and you can get photographs of when they built those houses in the 40s and 50s. And you can see they're actually right where they built them today. Kia ora whana, could you just mute your mic there for a moment? Kia ora. So yeah, that's got some really neat imagery in there. We've covered this RetroLens and other wānanga as well. What else can we do here? Let's see. If we want to look for a land block, let's say Te Hapua 42. It should come up. Hapua block's not coming up there. Okay, I might just refresh this. I'm not sure why the land block is not coming up there. Hold on, my whānau. When you zoom down, the links, the labels of the block should turn on. There we go, Te Hapua 24. Where is 42 gone? Can't be far away. Aroha mai. We can see here though, looking at using this layer tool over here, turning that on and off just by using that button. We can see there in the long term, you probably wouldn't want to be building much in these areas that are currently in red. You can see down here, these areas and these blocks along the coast here, they'll be impacted at some point, if not already. If we turn the red off, which is the kind of the extreme, and just see what are we looking at with 1 meter sea level rise, you're probably going to get some impact in these areas, particularly in times of storm surge, but not necessarily direct flooding from the sea. We come down here, have a look at this marae te reo mihi. So it's probably fairly low, fairly close to the coast, but not necessarily going to flood over here. And this is in 2 meters sea level rise in this area. It could be 100 years away still. So it's always never take anything at face value in terms of this. These are very generalized models throughout the whole country. So you want to just go through the data for your area piece by piece that you understand it. So it's not a, for example, I live in Petone, and we bought this place maybe 3 years ago, knowing that eventually Petone is not going to be here, but that's still 100 years away. So we're, people are still building houses in Petone, but most people will know that, eventually the sea will rise. The impact of floods, it'll start flooding at Petone, for example, before the salt water gets to us well in advance. There'll be some construction of stop banks, but in the long term, that's just not sustainable. So there are a few different types of sources, and there's another story map here just describing some of those, the science behind climate change and of course sea level rise. There's also this story map here, marae development plan. So how do you share this with others? You do the research for your mahi, for your block, for your whānau, for your marae. How do you share it? So this is one way that you can take all of this information and share it with friends and whānau. So this one's not specific to climate change. So this is a way that you can share maps, 3D, video, images, kōrero, recordings, all manner of things. And you can do this for free. This map here, this story map is showing you what you can do for free. You can do it on a free account from Esri or arcgis.com, arcgis.com. There are certain limitations on the free account, but at around November this year, all going well, there'll be a GIS Day event, and we'll have, well, they have in the past, Esri have made it some certificates available for people who are really keen to get a paid account, which gives you a couple of extra bits of functionality. So this is just an example of how you can share this kind of information, pictures, story, kōrero, 3D maps with friends and whānau. It's hosted for you, so it's shared online. So you just need to take into account, things like data sovereignty and things like that. If you're sharing it in public, however, it's a different story than if you're needing to keep it private.